First, we're going to look at some basic terminology having to do with the CPU so that we can kind of understand some of those terms as we use them later on, see what they mean. When we say system architecture in relationship to a CPU, we're really talking about a whole bunch of things. We're talking about the instruction set, for example, that the CPU uses. We're talking about the bus system, and we'll talk about buses later. There are basically three different kinds of buses. Those are those paths that go from the CPU to the memory, from the CPU to I/O devices, and there are also some buses internally in the CPU. It has to do with the amount of memory that it's capable of addressing, that kind of thing. So basically how that CPU, how the rest of the computer can be designed around that CPU. That's the system architecture. Now, I already mentioned what a bus is, and we're going to talk about those three bus types later on. When we say CPU, we're talking about that entire chip that performs the computational, the logical work on the computer. Specifically, we're talking about the core of the CPU when we're talking about what is doing the work of the CPU. And we'll talk a little bit more about the core in a couple of minutes. Now, a single chip is called a single processor. Now, that's the reason that sounds like it would only make sense, right? But it can be confusing today because we have multiple core CPUs. But let's take a look at this, and we're going to talk about multiple core CPUs in just a minute. But let's take a look at one particular CPU or one processor or one I'll just say, one processor or one CPU. It looks like this. And you see all these pins on the bottom of it. These pins are what make up these bus lines that you see over here on the right-hand side. So these pins go into these sockets, and those sockets in turn lead outward from this CPU socket and create these bus lines to memory and I/O devices and so forth. Now, let's start talking about those cores a little bit. Today we have what we call multi-core processors, 2, 3, 4, and more. The computer that I'm on right now has 32 cores on that CPU, but it is still a single CPU, and we can call that a die. So in other words, this is one die. Even though it has, in my case, 32 cores on that one die, it's still one die. It's still a single processor, even though it has multiple cores. All right, so we have multi-core processors, one processor with multiple cores, and we can also have multi-processor computers that have multiple cores, or I should say multiple processors, that is to say multiple dies or multiple physical CPUs on it. Now, let's take a look at what that looks like so that we can understand a little bit about why I'm making that distinction. When we're talking about a multi-core processor, here's a single processor or a single die, and it has multiple cores on it, but you notice it's sharing the buses. All the bus lines are being shared here. It's sharing the power. It's sharing in fact, it's sharing cache. It's sharing all of the stuff except for these individual processors themselves. Now, these cores are what are doing the work. Each core can run different processes, and they are the heart of the CPU. So in this case, this particular CPU, we'll say, kind of has multiple hearts, if you will. That is to say, it can do multiple things at a time, but it's slower than a case here where I have multiple physical CPUs because of the fact that it's sharing all of these things. All right, so it's not quite the same as having a multiprocessor. All right, let's talk about a couple of other terms. The reset vector. The reset vector is an address that's built into that CPU that tells the CPU where in memory to start reading when that CPU receives power. In other words, in RAM, or that's the memory I'm talking about, is RAM, whenever the CPU is processing instructions, it's processing those instructions from RAM. That's why we have to put the operating system from the disk into RAM. So that reset vector is where it starts processing. Now, there's also a thing called a program counter. The program counter is a register that keeps track of where it is. So, for example, if the reset vector, where let's say the reset vector is memory space 000000000, then as soon as it starts running 00000000, the program counter is set to 00000001. In other words, it is the next instruction for the CPU. So the program counter keeps track of the next space or the next address where the next instruction will be executed. So you need to know about the reset vector and the program counter. Let's see if we can visualize it a little bit. So here's the CPU, and it has built into the CPU where the reset vector is, someplace in RAM, someplace in memory. Now, what happens if you have multiple CPUs? Good question. If you have multiple CPUs, there is one that is dedicated as the boot CPU, because there is a place in memory where you have the boot information, and the CPU needs to start that boot information and start the process of booting the computer. So there is one CPU that would be dedicated as the boot CPU, and the rest of the CPUs would be application CPUs that can run the applications. Now here is what we call the program counter, and you can see again, if the reset vector is here, the program counter is pointing to the next space that should be run. Alright, let's take a look at a knowledge check. What part of the CPU is responsible for reading and executing machine code? Is it the bus? No, the bus is how we get stuff from one place to another. The control unit, well, we haven't really talked about control units. It would kind of make sense. It's not the register, because there are several kinds of registers. For example, the program counter is a register. No, it's the core, right? Let's double check that. Sure enough, the core is the part of the CPU responsible for reading and executing machine code. All right, thanks for joining us, and I look forward to seeing you in the next video.